The following is a presentation of the Control Trends Podcasting Network.
What is up, HVAC Control Pro? This is Eric Stromquist with Stromquist Company and ControlTrends.com. All right, question for you. Half wave versus full wave rectification in a valve actuator. This problem can drive you absolutely crazy. Never fear, because in episode 2 of the Control Trends Valve and Actuator Training, Control Pro Tim Chambly teaches you about that and how to overcome that problem. It can save you hours. So definitely watch this video to the end. It's a continuation of part 1, and Tim continues on with control signals and actuator tips and tricks to save you time in the field. So be sure to watch it to the end. Subscribe to the YouTube channel if you haven't, and I'll catch you on the flip side. I got something I want to tell you about.
The controller is sending 8 volts to my valve, damper, or whatever. We're almost fully open. Then something happens. Somebody cuts the wire. Someone is doing demo. You know, when you do demo, they just cut everything they can. All right, they cut the control wire. What's going to happen? Contrast that to, we've got a drive open and drive close relay, and you lose that. It fails to the last position. Not always, but typically. It kind of depends on how it is wired up. But does that make sense? There's a big difference between floating and proportional, but they both modulate. And by modulate, I'm talking about almost infinite number of positions in between open and close. That's pretty simple, isn't it? Okay. All right. And then back in the old days, we did have a 135 ohm resistance signal, but we don't see that as much anymore. We typically see 2-position or floating or proportional. Okay. Now, as far as the wiring goes, go by the instructions on whatever actuator you have in regards to wiring. But here, on this particular actuator, we've got 2 wires landed on power, and actually this thing is going to tend to have go in a clockwise rotation unless you put power on that terminal 3. So you've got common on 1, you've got power on 2, and then you're making and breaking power on 3. So without power on 3, you're going to rotate clockwise. If you apply power on 3, it's going to override it and drive it counterclockwise. So that's a little bit odd. I just want you to be aware. Oh, by the way, if you want to reverse, you can switch that action clockwise and counterclockwise. Again, that is specific to a particular actuator model and brand. So just be aware generically the difference between proportional and floating, and then specifically be very careful and be very aware of your specific actuator, how it wires. Here's another example. This is one that you power and it opens, remove power, it springs closed. You've got 2 wires. The first we just talked about has how many wires? We got 3 control wires. So 2 control wires, we've got 2 position, spring return, 3 wires, we've got, this would be a floating, correct? All right, now let's look at another one. This is a floating where you have a common that is always made, and then you've got your making and breaking of your drive open and drive closed. How many wires do we have? We have 3, but this is a little different from the first one we spoke about. So there's nuances here. So don't just think, oh, I've got 3 wires. I know what it is. 3 wires you don't really know. Here's 2 to 10 volt DC. How many wires do we have? Control wires. And it kind of depends on if we have feedback. Let's ignore the feedback for a minute. How many control wires do we have? We got 3. All right. We've got a COM and a hot and a signal. This is very, very common. Between this style and this style, I'd say 80 or 90% of your actuators will be one or the other of those. But they're both 3 wires, so the number of wires is not going to tell you what kind of signal it is. Just be careful and be aware. Okay? It's not hard, you just have to pay attention. Now, as far as our feedback signal, we ignored the feedback signal on this one. Now, this has end switches. Everybody can relate to end switches. You know, if it's open and closed, whatever, these are just built in. Some actuators have end switches. Now, some actuators, you may call us up and give us a model number of an actuator, and we say, okay, it's this actuator, this size, blah, blah, blah. Oh, we don't have that one in stock because we don't have the end switches. Well, you might actually have an actuator that the controller's not even using the end switches. So, you know, the end switches are optional depending on whether you're using it. And if you need an actuator, why wait to get an actuator with feedback if the controller is not using the feedback? All right. We've got to think about this. All right, so end switches. Everybody can relate to this? Simple? All right. Then let's look at this feedback. This is a little different. This is an analog feedback. So we've got a 0 to 10 or 2 to 10 signal coming back from our actuator. Okay. This will tell our actuator not that it's all the way open or all the way closed, but it'll tell us at what position it is. And sometimes our controllers want to know. Just depends on the controller. Okay. So far, what's difficult? It's pretty straightforward stuff, isn't it? As long as you pay attention to what you have and what you need. Pretty straightforward. Sometimes instead of having a 2 to 10, we have a 4 to 20 milliamp signal. It depends on the controller. And that just, you know, says we got a 500 ohm load in there. Again, if you're not sure about that in your particular application, call us. We could probably guide you through this. It's not a problem. Sometimes 4 to 20 milliamp signals come on 3 wires, some on 2 wires. We have to know. All right, there's a difference. Okay. Now, if we have a controller actuating some type of actuator, this is your common wiring. It's pretty straightforward. We've got power going to the actuator. We usually tie our commons in to the actuator, to the control board, and then we get a signal. In this case, it's showing a 0 to 10 volt signal coming from our controller to our actuator. So, how many wires do we have? It depends on what I'm referring to, right? But it's 3 wires going to the actuator. And then, but now I've got 2 wires here and I've got 2 wires here. This is going to be probably in the same cabinet here, so how many wires do I have going out to my actuator? I still have 3 wires, right? Because my common is tied together. Okay. if this guy is doing some weird things, just be aware, electronics like grounds, okay? And probably most of you, if you've been doing this long enough, you have found a situation where the board is good. Everything is good. All the wiring is good, but it's still acting up. Check your ground, okay? Because bad grounds can do some weird things, right? Drive you nuts. Now, here's another thing. If I don't know if anybody has ever gone through this before, but if you look at the drawing, everybody sees this little symbol right here. What is that? Diode. It's a diode. And what does a diode do? It's like an electrical check valve. So if you put AC into it, alternating current from positive to negative, this will allow only part of the signal. What will come out is just the positives and negative is clipped off. Pretty simple. Everybody with me? Now, back in my college days, I took electronics, and they taught me that if you make an array of these things, then what will happen is we put power in. What comes out is, it does not look like this. It passes the positive, and it also passes the negative, but it looks like a positive. It just flips the negative up to the positive side. Does that make sense? Okay. And then if we were to look at this board, okay, and I'm not wearing my glasses, but I bet you could see what powers this board. What voltage is this board? Do you see it?
AC.
It says 24 volts AC. Good eyes. But they lying. This is not an AC board. This is a DC board. Although you power it with AC, all electronics uses DC. It just converts to DC. All right? Where am I going with this? Am I just off in Never Never Land? Let me tell you a story. Got a customer, had an application in a lab. In this lab, they've got liquid nitrogen and they've got liquid helium in canisters in this lab. And what they wanted is, in the event of a leak, they wanted an exhaust fan to come on. And part of this thing, they wanted a VFD to control the exhaust fan. And so we wanted a certain minimum amount because we wanted to keep the room slightly negative. But in the event of a leak, we wanted this thing to ramp on up. And let's take care of this leak. All right, so we're looking at helium and nitrogen. They've got different weights. The helium is a lighter gas. Nitrogen is a heavier gas. So in this room, if one leaks, our problem would be high. If the other leaks, our problem would be low. Does that make sense? So what did we have to do? Well, we put a sensor high and we put a sensor low. We actually went with oxygen sensors, oxygen deprivation sensors. These sensors we tied into a little box that mixed the signals and sent out the lower of the two. All right, this went to a VFD which controlled the fan. All right. So far, not real confusing. It's okay. We just have to be careful with the wiring. It's not that big deal. So we've got this controller in a control box. This is 24 volts. This is 24 volts. This is 24 volts. All 24 volts AC, right? So we pop a transformer in here, 24 volts, and we power all three boards, because all three boards, they don't consume a whole lot of electricity, and that one transformer had plenty of power to do all three of these boards. You with me? And so once we got this system all hooked up and we're ready to test it out, throw the switch, pop a fuse. And one of these guys, okay, a lot of wires going. You've popped control fuse. This is no big deal. What do? You put another fuse in there. and of course that pops. Well, but first you check your voltage, make sure you got 110 in, 24 volts out or whatever. And then you trace your wires, make sure you made your terminations, and then you decide it's wired up, so what do? Put another fuse in. It pops. So what is the next step? You recheck the wires that you just checked, right? And everything is right, so what do? You put in another fuse. And what happens? It pops. Then what do? You're out of fuses, you got to go buy more fuses. and so, go through the wiring again and double and triple check the wiring that you double checked that you originally checked, right? Everything is perfect. What's going on? I mean, we wrestled with this for hours. And finally, I'm on the phone with the tech support at the factory, and they said, oh, by the way, maybe you've got a situation where you've got full and half wave rectification boards mixed. Half wave, full wave. All right, 24 in, and then it powers whatever it needs to power internally. Don't mix the two. All right, now that was a long path, long story, but what I'm trying to do is impress upon you, because when the guy told me, I remember way back in electronics school, they taught me that. I had just forgotten. And it didn't occur to me until they mentioned. So one of these days, if you find yourself in a situation like that, be mindful. Oh, and by the way, on the box that the controller is in, or on the controller, it'll never tell you if it's half or full wave rectification. All right? I gave them, these two had their transformer, and this guy had their transformer, a little old $15 transformer, and a little bit of wiring, problem went away. After hours of agony. Yeah. So, and many fuses. And so, I could have just put this slide up and said, don't mix half and full, but kind of goes in one ear and out the other. I don't know, if you're like me, it's hard to remember this stuff because we got so much going on. That's why I belabored the point. So actually there's two things I want you to take away. One is difference between proportional and floating, and everybody's okay on that. And then one of these days, if you're scratching your head and you're popping fuses or burning this might be your problem. And specifically with Belimo, their stuff, don't power this with the same transformer that powers this because this uses full wave. Everything else Belimo has uses half wave rectification. Make sense? Okay. Now, let's talk about valves.
Okay, great stuff from Tim Chambly. Hey, episode 3 of the Valve and Actuator training, Tim is going to break down the different types of valves, from ball valves to globe valves to butterfly valves and more. I'll get that posted here in the next couple of days. But hey, I'm getting ready to do some traveling. I'm getting ready to hit the road. I head to Haystack next week, and after Haystack, I fly directly to Amsterdam for the EasyIO Global Conference. Okay, so I might be out of pocket a little bit. We'll be posting videos from Europe and from San Diego with Haystack Connect, which is what I wanted to tell you guys about. Okay, I don't know whether you're on Instagram or not. If you are, definitely follow me, HVAC Control Pro on Instagram, HVAC Control Pro. Ought to be easy to remember because you're an HVAC Control Pro. I like to think I'm an HVAC Control Pro too. Now, why would you do this? Well, if you on Instagram, you know there's a feature called live streaming. We did some Instagram live streaming from the Cochrane Controls Con conference last week. The Instagram followers loved it. So, hey, get on the bandwagon. Get on that bandwagon. If you're on Instagram, follow me at HVAC Control Pro, and I'll follow you back. All right. Till we see you again, be bold, stay in control, and stay relevant.